in this case, we're given a triangle that has two sides already shown to us, B and little b and little a. And we're told that angle B is 31 degrees. Okay, that's nice. And we're given this fourth piece of information here. We're told that angle A is obtuse. Now, you might have guessed that from the shape, but you really should never jump to conclusions. In this case, it comes out and says it. Angle A is obtuse. Solve for the triangle. Okay, I'll show you why that turns out to be a pretty useful clue here. Let's start solving this thing first by figuring out what angle or side we should go for first. Take a look at what we're given. We're given, let's see, angle B. Okay, we're told angle B. We're told little b right there. We're told little a. And if you think about this, notice I've got a pair of b's. Okay, the b's are matching. And the question is, what can I solve then in my law of sines? If you remember what the law of sines is, it says this. Well, here's one form of it. Big A over little a equals sine of big B over little b equals sine of big C over little c. So we're looking at this thing, we're trying to think what to solve. Well, I don't know the angle C, I don't know the side C, so there's no point starting there. We're going to have to go for A. Okay, we're going to go solve big angle A. Now, I'm going to do, I think I can fit the work right here. Let's take this portion. Okay, I'm going to take this portion of my law and rewrite it right here. I'm going to say sine of big A equals little a times the sine of b over little b. See, I just multiplied each side by little a. This should get much easier to solve now. I get, let's see, 7.17 for little a times the sine of angle B is 31 degrees. Okay, no, I don't like that multiplication there. I'm just going to do parentheses. Okay, divided by little b is 3.75. So this is the way you should type it into your calculator. And what we get is that the sine of angle A equals, well, let's see, 7.17 sine of 31 degrees divided by 3.75. Okay, great. I get 0.984, I'm going to round it, 9848. But notice I've used a lot of digits. And when you do round, make sure you have a lot of digits, 4, 5, 6, something crazy like that. So that then we do A equals the inverse sine of the answer, that last part, 9848. And we get A equals, if I do the inverse sine here on my calculator, okay, I get A equals 79.98. I'm going to use lots of digits, 9819 degrees. Okay, hold up, we got a problem. Because I was told at the beginning of this thing that A, the angle A, is obtuse. And look what we just had. We just solved for an acute angle. So we have to figure out how to resolve this issue. And I like to talk about the unit circle every chance I get. If you remember what the unit circle looks like, okay, we've got this big circle here, and the sine of 79 degrees is going to look something like this. It's this y value here. See how high up it is? There's my sine, that dot I just drew, the y value. Well, what other value is the same thing? Where else is the sine of an angle equal to that y value? If you just look across this unit circle, okay, cut a little line over here, you see that right here, that's going to be another place where I have the exact same sine value. In other words, the y-coordinate is the same. So we just have to find what that angle is right here. I'm going to draw the angle. It's all the way over there. So the way you find that is doing this. You say, hey, I need an obtuse angle. Okay, I'm just going to put a little hat on this to make it different. You say, my obtuse angle is 180 degrees minus that first one I just found. Okay, so we type that in here. 180 minus our answer, and we get this. We get our angle A equals 100.0181 degrees. Okay, so question is, which one of these is right? Because they're both possible angles that would satisfy the law of sines. Well, the answer is the obtuse one, because we're told it's obtuse. So we have to use that here. 100.02 degrees. Okay, now you're moving on. I think the rest of the problem should be fairly straightforward. but I'll just give you some reminders of how to do this. Let's change ink here. How about angle C? I want to go for angle C next because I can't get little c. Okay, I don't have anything about the c's to work on, but I can get big angle C without even using the law of sines, just by remembering this. A plus B plus C equals 180 degrees. Okay, so that means angle C equals 180 degrees minus 100.02 degrees minus, what was my other one? 31 degrees. Okay, so that tells me that angle C is 48.98 degrees. Great, that was easy. Now we can move on and find the side C. That'll be my last step. So I use a version of the law of sines, which will be easy for me. Little c over sine C equals, let's just pick little a. You could do either one you want at this point. We know just about everything. So that means little c equals little a times the sine of angle C divided by the sine of angle A. Okay, and we know these values. Where is little a? 7.17. So this is 7.17, that's little a, times sine of 48.98 degrees, that's big angle C, and angle A, remember we're going to use the obtuse angle, 100.02 degrees. And if you punch that into your calculator, you will get C equals 5.49. Okay, so that's the way we work through this one. I think the key point is right here, this guy. How do we deal with an obtuse angle? You do 180 degrees minus what your calculator told you, and that gives you the obtuse angle, not the acute one.